Hi, I'm Thomas Swimber, and today I'll be presenting my STEM Impact project. Uh, my introduction focuses on how bees play a crucial role in pollination and agriculture. However, many beekeepers do not have access to information about what is actually going on inside their beehive. Traditional inspectors require opening the hive. There are many invasive approaches that damage the ecosystem within beehives, and in general, it would be great if there was a method for beekeepers to access data about their hives without needing to open it up. The goal of this project was to create a self-contained sensory package that could be placed into any beehive regardless of shape or size and upload data to the cloud regarding important indicators of beehive health and honey production, including weight, VOC, temperature, so on. The design requirements I identified were the system needs to be able to measure the indicators of hive health, as previously mentioned. It needs to be compatible with any beehive type. It needs to be weather resistant, capable of being powered for a considerable amount of time. The benchmark I found was a week. It needs to support wireless communication. It should be able to maintain an internet connection during all operations. It should be able to upload data at any time of the day. And yeah, this project was initially based off of a previous project I'd worked on where I restored a beehive that had numerous sensors already inside of it. This project simply aims to take those same sensors and create a sensory package to be placed in any beehive. The original beehive contained a Raspberry Pi and an Arduino to monitor data. However, I thought this entire setup was a bit clunky and unnecessary, so I decided to use an ESP32 microcontroller. It had the required computing power and ability to use multiple programming languages I was familiar with, as well as import packages for database providers and so on. It also generally has low power consumption and links perfectly with any other sensory packages with any other sensors I would like to include. Um, for sensors, I initially selected a simple temperature sensor and a load cell. Uh, Creating the integration for the load cell was definitely incredibly difficult, primarily because a lot of Kenyan beehives are barrels that are held from trees. Due to this, I needed to develop a way for the load cell to measure tension, not direct weight. To do this, I created some brackets in Fusion that would hook onto 2 points on the string attached to the tree by which the beehive is hanging, and it would measure the tension between those 2 points, thereby creating an accurate measurement of weight. A lot of my initial development focused on getting this system working, of which I successfully did. To do this, I simply 3D printed the two load cell brackets I designed and tested using an Arduino, where I was able to get find the using a known weight. I was able to find the weight calibration factor in my code in order to get accurate weight readings from the tension based weight mechanism. The physical design of the package is very simple, designed by a member of the design studio club. The package is simply a 3D printed box which stores sensors with holes for sensors with holes for different sensor probes to enter the beehive without the entire package needing to be placed inside. Uh, Overall, the initial as I continued to work on this project and um, yeah, in general, as I was working on this project, I also started working on IC Esteem, which took a significant amount of time out of this particular project. In particular, the ESP32 I was using went missing, meaning I was forced to switch to an Arduino RP2040 Nano. This part of the design wasn't actually too difficult. Switching the code was fairly simple. The main challenge here was finding a good method to display data from the beehive. I initially experimented with Arduino Cloud, but Arduino Cloud is only capable of providing up-to-date information, not long-term history as Google Sheets is, or perhaps a dedicated data provider. To rectify this, with the RP2040 Connect, I hosted a Node.js server on a Railway virtual machine. This server had a connection to MongoDB, allowing the Arduino RP2040 to send post requests to the server, which would then use the MongoDB JavaScript driver to upload data to MongoDB, allowing a beekeeper to see data from their beehive. Unfortunately, I didn't have enough time to implement the temperature, humidity, or other sensors. So far, the only sensor that has successfully uploaded data is the load cell. However, the bulk of this project has been finished, and as a continuation, putting the actual project into the box and testing it within an actual beehive would be the natural continuation of everything done so far. All code is currently listed on a public GitHub repo under my GitHub account, meaning it should be easy to access and implement. And with that, that is the bulk of the project. In terms of my personal reflection, it was generally a fun project to work on. Time was a bit constrained due to exams and ICSD and other passion projects I was working on at the time. But overall, it was a good project. Happy I completed it. And that ends my video. Thank you very much.